So actually, z-scores can be calculated for anything with a mean and a standard deviation. Okay, z-scores are most useful when we have z-scores for a normal distribution. They're very useful, but technically, z-score is just how many standard deviations we are from the mean, and it can be calculated for any distribution where you have a mean and standard deviation defined by the distribution, or any set of data where you have a mean and standard deviation calculated from the data. Okay, so
It has no unit.
yeah, z-scores have no unit or the unit is standard deviations, but you don't say that, right? Okay.
So can they be used to compare?
Yes, that's exactly what we will be doing. Okay. All right. So the normal model has this interesting property in that if something follows the normal model or normal distribution, okay, they will all have the same proportions if you turn the normal model into z-scores. Okay. So we could look at the heights of men. All right. And we could find out, what proportion of men have heights with z-scores of -1 or something more negative, or what proportion of men have heights with z-scores of 2 or something more. Okay. And we could look at the heights of women, and if we change the women's heights from whatever inches or centimeters that they're measured in, and we turn them into z-scores, the same proportion applies to them. So if 2.5% of men have z-scores of 2 or more, the same applies for the women. 2.5% of women have z-scores of 2 or more. Okay, this property holds for everything. Okay, we could look at elephants and their weights. If they follow a normal distribution, we would say 2.5% of elephants have z-scores of 2 or more. We could look at I don't know, squid length or whatever it might be. Anything that follows a normal distribution, the same proportions hold for all of them if you turn them into z-scores. Okay, and this is kind of a neat property of the normal distribution. So if we turn measurements into z-scores, okay, and we know that they come from a normal distribution, okay, the same proportions and probabilities will hold for all of the z-scores. And so when we turn them into z-scores, we have what we call the standard normal table. And what the standard normal table tells us is the area shaded to the left of any one particular z-score. So just to check our understanding, what is the z-score of this point right here? 0. Right here, z is equal to 0. Okay? Is everyone good with that? Because we're right at the mean. The distance from the mean is 0. Okay. And so if I shade everything to the left, how much do I have shaded in terms of proportion? Yeah, 50% or 0.5. Okay, so if I shade everything to the left, the area shaded to the left of z equal to 0 is 0.5. Okay. And if you look at your table number 3, areas under the normal curve, okay, actually flip it over to the other side. The first page is the negative side, okay? If you look at that table, you'll see in the top left-hand corner 0.0 and 0.00, and the number in that top left-hand corner is 0.50000. Okay? And what that means is that if z is equal to 0.00, the area to the left of 0.00, area to the left is equal to 0.5000, okay, or basically 0.5. So z equal to 0, the area to the left is 0.5. Is that okay? All right. And so if we went just ever so slightly, if we went 1/100th of a standard deviation to the right, so now z is equal to 0.01. So we are 1/100th of a standard deviation. So we just have a tiny sliver more than 0.5. The amount that we would have shaded to the left is right there, 0.5040. So 50.4% if I go just a tiny bit of a sliver to the right. Is that okay? All right. All right, so if let's say I am, what did I say? So, I left this out. Okay, let's just say I am 1.67 standard deviations above the mean. So z is equal to 1.67. I would look up the row 1.6 and the column 0.07. Okay, and how much is shaded to the right, left of 1.67? 0.9525. Is that okay? All right. Okay, so let's just look up some of these numbers here. All right. So we said I just erased it. But I said, you know, approximately what percentage of men are taller than 76 inches? Okay? So 76 inches corresponded to a z-score of 2. And I said, approximately what percentage of men are taller? And so from the empirical rule, we knew that the answer is about 2.5%, right? Because 95% is within 2 standard deviations, so that means 5% is beyond 2 standard deviations. And so if we just look at the top side, we have about 2.5% are beyond a z-score of 2. Okay? If we look up a z-score of 2 in the table, what is the number that we find? Yeah, so we would look up the row 2.0 and the column 0.00, and the number I would get is 0.9772. Is that okay? All right, so z equals to 2 implies 2.000. So I would look up the row 2.0 and the column 0.00. Is that okay? That z, when z is equal to 2, I'm going to 2.0 and 0.00. Alright, so you guys are all good. In my other class, like, a lot of the students struggle with this, and so I just want to make sure I'm not, I don't want to bore you to death either, but I just want to make sure we're okay there. Okay, so we get that the area to the left, okay, is 0.9772. So when we look up z is equal to 2.00, the area to the left is equal to 0.9772. But this question is asking what percentage of men are taller. So what do I have to do? I would subtract this number from 1. I would do 1 minus 0.9772. And we would get what? 0.0228. Okay? So what percentage of men are taller? Not exactly 2.5%, but 2.28%. We could just have looked up z equal to -2. That's also very true, okay? And so, because the z table is symmetric, anytime somebody asks what percentage is higher than something, because the table always gives you the area to the left, you could just look up the negative value, or the inverse value, or no, not inverse, the negative value, and the area to the left of the negative value is equal to the area to the right of the positive value. Okay. Yes?
So on a quiz or an exam, could either answer 2.28 or 2.5 be acceptable? You have to like look it up?
So, yeah, I would say on quizzes and exams, look it up on the table, okay? The empirical rule with the 95%, 68%, all of that, those are good rules of thumb that I would say best serves as kind of just like a reality check, I should say. You know, you should, if you get some answer and your z-score is 2, then you have to think, well, is this something where I would expect about 1 in 20 to have be this rare or something, okay? And if it seems strange, then maybe you can reevaluate that. But I would say go with the z-score and look it up. Okay. Okay. Yes. So instead of looking up z equal to 2 and getting 0.9772 and doing 1 minus that to get 0.0228, you could look up z equal to -2 and find that the area to the left of -2 is 0.0228. Okay. Also valid. If what I said didn't make sense, don't worry about it. You can go with this method, and it will not lead you astray either. Okay, but we're always, the key here is it asks what percentage of men are taller. So when we say taller, we are meaning that height or more. So we are going for the area to the right and not the area to the left. Okay, and this also serves as kind of a common sense check, where does it seem like 97% of men are taller than 76 inches? No, our reality would say no. 97% of men or 98% of men are not taller than 6'4". So something's probably off about my answer, and that would clue you in. Oh, I should subtract from 1. Okay. So always be thinking like, does this answer even make sense in the first place? And that will help you avoid some common mistakes. All right, so let's just try a couple problems here, a couple drills. All right. Let's pick an animal here. What do you think the size of the average giraffe is? How heavy do you think an average giraffe is? Weight of giraffe. Let's go Google. Let's see. Oh my gosh. They're huge. Okay. Average male giraffe. Guess how many kilograms? Average male giraffe. No cheating.
200.
Huh? 1,600 kilograms. That thing is massive. That's like 30 3,500 pounds? Okay, so male giraffes, weight. Like my daughter loves to play with these little stuffed giraffes. Who knew that they were like these bulldozer tanks? Okay, all right, so the mean, 1,600 kilograms. I have no idea what the standard deviation is, but I'm just going to make up a number, okay? We will say 150 kilograms. I have no idea, okay? All right, so I'm going to say what percentage of male giraffes weigh less than 1,725 kilograms. All right, so start off with that one, and then I'll put a second question up. All right, just start off with this first question, and I'll give you a couple of minutes to solve that. So sorry. All right, how are we doing? We need another minute. Are we good? Okay, well, nobody said anything, so we'll go. All right, so if I were to draw a picture, I would put the mean right here, 1,600. kilograms, and I would draw a line over here at 1725, and I'm asking what percentage weigh less than 1725 kilos. Okay, so my z-score would be 1725 minus 1600 over 150, and I would get 125 over 150, and I would get 0.8333. So I look this up in the z-table. Z-table only goes to 2 decimals of precision, so I've got to round off to 2 decimals, so I'm just going to use 0.83. So I go to the row, 0.8, and the column 0.03, and the number I find there is 0.7967. Okay. So our answer is about 79.67%. Okay. Good? Good? All right, thank you. Thank you for your thumbs up. All right, what about this next one? What percentage of male giraffes weigh between 1,500 and 1,725 kilos? Okay. Well, half of our work is actually already done, and to answer this one, my picture, if I draw it, looks like this. 1,600 in the middle, 1,725 off to the right, 1,500 off to the left. Okay. And what I'm going for is this area in between the two lines. And so to get that, I'm going to take the area to the left of 1,725, which I've already done, and I know this is equal to 0.7967 from the previous problem. And then I'm going to find the area to the left of 1,500. Okay, so this we have not done. And I'm going to do this area minus this area will give me the area in between. Is that satisfactory to everybody? Okay, so now it's just a matter of finding the area to the left of 1,500 and subtracting that from the area to the left of 1,725. Okay, so go, go, go. Question?
Would you like a 4 sig figs on a test?
Sure. My rule of thumb is round only when you have to. You know, so when you look up a z-score on the table, you have to round off to two decimals. I'm not going to try to have you interpolate values in between. We could, but that seems unnecessary. All right, so I'm getting 0.5453. Area to the left of 1725 is 0.7967. We did that in the previous problem. For 1500, I get a z-score of negative 0.67, which corresponds to an area of 0.2514. I take the difference between those two, and I get 0.5453. Is that okay? All right, why don't we take a 10-minute break, and then